In Diva, we are trying to push for a solution that needs to be as good at the level of competitiveness as Lido, but with the centralized values that we want in Ethereum. But still, you could say, okay, but what if you grow at the same point of Lido, right? You could be the good, the perfect, the ideal saver, but still be as big as Lido, and then you become also part of the problem instead of being the solution. So we agree with that, and I think the community has already been voting and discussing about these kind of things like the self-limitation of the protocol, trying to limit ourselves inside the whole ecosystem of liquid staking, unless Ethereum decides to natively, which is something that Vitalik discussed on one of the latest posts, to introduce some kind of liquid staking or native staking inside of the protocol, which could be something that Ethereum does, but in that case, I hope that we can be part of the conversation.
In this episode, we talk with Miguel Prada, who is the tech lead at Diva and the CEO at Shamir Labs, which is the company behind Diva. Kevin, I'm curious what stood out to you in this episode.
Yeah, this was a really cool episode. We talked about the Lido dominance concerns. We talked about liquid staking, how that kind of works at a high level, this introduction of this concept of DVT, distributed validator technology, and the way that it breaks down individual validator into many different operators and what that does for the protocol, how that could potentially decentralize it further. And Miguel did a really great job diving really deep into the nitty-gritty about how Diva does this. Was there anything else that stuck out to you, Chase?
No, I always think these types of things are really interesting because ultimately, we talk a lot about decentralization and why it matters, but these things really do matter at the protocol level. And so there were a couple of really interesting conversations around exactly how we make these things secure, but also flexible enough. And yeah, it was a really interesting conversation. I feel like I learned a lot. So I hope everyone enjoys it as much as we enjoyed recording it. We are here with Miguel Prada, who is the tech lead at Diva and the CEO of Shamir Labs, which is the company that is building Diva. So, Miguel, very excited to have you on the pod.
Thank you very much, Chase, and happy to be here and share with you all that we are doing.
GM, Miguel.
GM.
We're very excited to talk about liquid staking and all of the things that you're working on at Diva. But before we do that, maybe you can introduce yourself and give a little bit of context around how you got involved with Diva, how you got into liquid staking, all of that.
Yeah, so I started getting involved into crypto around 2013 with a group of friends in Sevilla, in the south of Spain. And since then, we were quite active in crypto. We are looking at every project and got involved at Ethereum very early. So I was doing mostly my PhD and then here working at Switzerland. And at some point, I just decided I wanted to get really active, like developing and putting my effort on the day-to-day basis on the open ecosystem. So together with a friend from Dabnot, Edu Antuñez from the Dabnot team, we participated on ETH Lisbon Hackathon in 2021. Where we started this idea of Diva, like a two-sided pool where you have a pool of stakers and a pool of operators, and you can join them together so they can start validating on a distributed way. So we started this idea, but I was the only one continuing with him, with the project. So yeah, I took the lead and decided to call another few friends that were working with me in the past, colleagues from the university and colleagues that I knew that were the right people. Is like calling your best teammates to be part of this project, and we decided to try to build it together. And yeah, over the last year, over 2022, many of my co-founders joined. So in total, we are like 6 co-founders, and they joined at different points in time. But that's how the project started on a single hackathon. We didn't win at all anything, so you see that things can end well even if you don't win a hackathon.
Yeah, I've definitely had my fair share of like hackathons where the only thing I win is my sleep afterwards.
And some friends also.
And friends.
Yeah. I mean, I guess you gave a little bit of context around some of how Diva works and how you're thinking about this. Maybe at a very high level, for people who are not super familiar, we can start off with the problem that Diva is trying to solve at its core.
All right. So at Diva, we decided that building liquid staking was too easy, and we tried to tackle too many problems at a single time. So instead of solving one, we're solving different problems. One of them is for the stakers. What problems do the stakers have? Well, they want to stake, but they maybe don't have the technical capabilities, the machines, they don't want the time to get involved around running a node at home. So they want just to get some yield over their Ethereum, and they want to use that cash to generate some passive revenue, right? So that's what generally a staker wants, this liquid staking revenue, and use this token, the representation of the stake ether on DeFi. So that's what liquid staking solves. There were already other solutions in the market, but we wanted to tackle this problem and at the same time lower the barrier of entry for the operators. So currently, if you want to have a really decentralized pool of operators that run Ethereum validators, there were not really many solutions. The main one was Rocketpool. They are great. They are doing great product. However, the high barrier of entry on their amount of collateral required and decentralization of the key management, like who operates the nodes, was too much. Like you needed to be really active in managing these nodes. So with the technology called DVT, distributed validator technology, you can decentralize the validator across many nodes. So is the network is a group of nodes that behaves like a validator, solving this issue of also a complex operation with a high barrier of entry. So these are the two main problems that we are solving, the stakers one and the operators one. Yep.
Yeah, and I think this is a really timely episode with the conversation that's been going on in crypto Twitter around Lido dominance. Can you talk a little bit about how liquid staking has this sort of inherent property where the economies of scale kick in, and as we're seeing with Lido, there's sort of this concern of like a push toward a centralized layer on top of Ethereum. Can you talk a little bit about like what that fear is right now and then the way that affects Diva?
Yep. So, of course, there's fear. I think in the whole Ethereum community, like we started building Diva because overall we have been Ethereum maxis since the beginning. Like we want to protect Ethereum and make it better and not the other way around. So the thing is that if any protocol becomes too big, de facto becomes the protocol of staking on Ethereum. And that's the problem that Lido can face and also any other protocol could face. So I understand the concerns of trying to limit, because anything that becomes too big is basically de facto what is controlling the staking on Ethereum. In that case, I think the only thing that can decentralize is when you have multiple solutions. So the real competitiveness right now, I don't think it sees a real competitiveness on the market. Like Lido is too good. Like we have to be honest. They have a good interface. They have a good project. They have some community and the right development. So they are growing because they are doing some things that are right. That's why they are growing. However, they need to be also self-aware of this, behavior, because it can cause a damage. Even when you try with your best intention to create a good thing, it can be bad for Ethereum just because of the selfness of trying not to limit yourself. So in that case, I think that's why in Diva, we are trying to push for a solution that needs to be as good at the level of competitiveness as Lido, but with the centralized values that we want in Ethereum. But still, you could say, okay, but what if you grow at the same point of Lido, right? You could be the good, the perfect, the ideal saver, but still be as big as Lido, and then you become also part of the problem instead of being the solution. So we agree with that, and I think the community has already been voting and discussing about these kind of things, like the self-limitation of the protocol, trying to limit ourselves into inside the whole ecosystem of liquid staking, unless Ethereum decides to natively, which is something that Vitalik discussed on one of the latest posts, to introduce some kind of liquid staking or native staking inside of the protocol, which could be something that Ethereum does, but in that case, I hope that we can be part of the conversation and help shape that. Yeah.
What happens when a small set of actors like Lido holds a large percent of total staked ETH? There's 3 lines in the sand. There's 33%, 50%, and 66%. And at each of these points, a single staking entity can inflict varying amounts of damage on the protocol itself. Did you want to talk a little bit about those?
Yep. So at 33%, an attacker or like a group of people or a network could already start finalization. This means that the network cannot gather more than 2/3 of the signatures to be able to progress. Around 50%, they can already start creating censoring blocks and deciding what to include or what not. And over 66%, they can already fork and decide they are virtually the network, because once you have more than 2/3, you are able to finalize and also decide where is going to be included in the network. So you have full control over the network. So you become the network, you are the network. And that also becomes a big problem. That's something I talk about it on Denver. If you have a DVT, and it's something we are really taking very seriously on Diva, people think that DVT is only good, but there can be also evil with it, which is basically once you have a threshold, the threshold also becomes the controlling majority over the validator. So if you have control 2/3 of the validator, if you have 2/3 of the threshold of all these 2/3 of the validators, right, with the combination of both, you can have way lower amount of controlling keys or collateral to be able to control a big portion of the validator. So you have to take into account this into the risk modeling of the protocol, or otherwise DVT could be also in detriment in some kind of scenarios if you don't do it properly. Yeah.
Got it. Okay. So I think that's helpful background as we start to talk a little bit about what Diva is. And you had mentioned DVT, distributed validator technology. Can you first just sort of define like what that enables for a liquid staking protocol like Diva?
Yeah. Also, Lido is going to use it. Like, in general, DVT is a concept that started on the Ethereum Foundation. And the idea behind it is, well, the concept, if you look at the specification, is very simple. The keys need to be shared. So instead of having one key into a single machine that is signing and acting as a validator, you have the key split across multiple machines, and they all signed a partial version of the message that need to be signed. That's one part of the thing. And the other is that they all need to agree on what is going to be signed. So one thing is signing, but the other is agreeing on what needs to be signed. And that combination of a consensus to decide what needs to be signed and signing those pieces so you can aggregate them together is what DVT stands for this distributed validation technology. Yeah.
Got it. Yeah. And then I think that segues us into Diva. Just, I have to ask, does the name Diva come from DVT? Is that partially
yes,
at least?
A little bit. It comes from distributed validation, actually, from Diva. So not very original though, but I mean, it's kind of a catchy name. It's easy to pronounce, and I think people got it, and there are already many memes, and it's a playful name, I think. Yeah. So
I like it. Okay. So then at a high level, what is Diva? And then we'll dig into the sort of low level components next.
Sure. So at Diva, we decided that DVT was going to be a core part. So we started not from the liquid staking, but from the DVT part. When going up, we decided that in order to have something really distributed validating in Ethereum, you need to build the vertically integrated protocol that connects all the parts. So validators here need to be created on a random process, on a distributed way. So what Diva is, as I mentioned at the beginning, you have a group of stakers that don't want to run validator. They only want to stake ethers, and that's it. They want to deposit the capital. And then you have people that want to put the effort, put the machines, do the work, right? So what Diva does is just putting these two groups together, and they match them together. You put some ethers from this part with some technical capabilities from the other part, and you connect both parts, so you have a network that validates on behalf of these both entities from both areas. So that's what Diva does, and it does it in a distributed way thanks to the DVT technology that you mentioned before. Yep.
Yeah, and I think from my understanding, the value proposition that introduces with Diva is that someone only needs to introduce one of their own ETH in order to run a Diva node. Could you talk a little bit about that and like why that's so low?
Yeah, so the one ETH number right now is not something that is written on stone. It's something that we are just pushing at the beginning. But the idea is could be one ETH or even lower. And why lower? Well, maths are pretty simple. You take the same risk of analysis of Rocket Pool, where you see that it's safe enough to have a collateralized operator of around 4, 8 ethers, whatever amount. And then when you divide that by a set of operators that are going to be running the validator, each one of the operators is going to require only, in the case of operators of 16 nodes per validator, you have 1/16 of the whole validator collateral. So then you have 1/16 of 8 or 1/16 of 4, and then you can have up to, let's say, 0.5 ethers or something like that per operator. But what that gives you is a key share. You don't have full control over the validator. No one does. You have only a share of the validator. And that's what allows you to have revenue over a small portion of ethers and to lower that barrier of entry for anybody. So if you have only a small amount of ethers, you can already become a part of the network and contribute somehow.
And so just to play that back, in one scenario, you have an at-home staker, someone who has 32 ETH that they want to stake for their validator. And Diva now breaks that into 16 different random nodes, like a collection of 16 different nodes, where each node, the person running the node introduces 1 ETH, and then they take an ETH from people that have chosen to stake into Diva, people that don't want to necessarily run a node. Is that right?
Almost with a slight tweaking. So you don't have 1 ether of collateral per the whole validator. You have a bit more. You have 4 or 8. So let's assume to have round numbers, let's assume that you have 16 of collateral from the operators, okay? And then you have 16 operators per validator. So then you have 16 ethers of collateral between 16 operators, 1 ether per operator, right? And then you are missing another 16 ethers. Where do they come? From stakers. So a staker put the other remaining 16 ether together with the 16, 1 per each one of the 16 operators, and there you have the 32 ether validator that is running by these 16 nodes. Does it make sense?
Yes. Okay, that makes more sense.
So just to be clear, the 16 number is not necessarily where things will be in the long run, right? You could have more than 16 individual stakers or individual operators, right?
We need to run a bit more of analysis, so we are going to use this tool called Kurtosis that the Ethereum Foundation is also using to try to model how big or small can be these sets. So we haven't run analysis to know maybe it can be that every validator can be run by 32 nodes or by 16 or by 5, because maybe we find a bottleneck. So that number needs proper study. Otherwise, it's just a number taken out of the hat, right? So we need to properly study. Right now, we are giving that number to give a rough estimate to people to understand how Diva works, but the right number at the end will need to be decided on the future. Yes.
Yeah. And I guess I'm curious, like intuitively, is your assumption that the more individual entities you can bring in, do you think that provides a certain level of decentralization type of thing? I'm curious how you think about how distributed a single, I suppose, it's not really a node, but I don't know what the entity itself is that's made up of all of these individual nodes. But yeah, I'm curious if you think more distribution is better.
Yeah, it's a fantastic question, Chase. So the way we call it is an operator in Diva can have many nodes. So you can have many nodes running. It's like you as a person can have many cars, and the cars are the machines that work for you, right? So you can have many nodes, you can have many cars. Same kind of analogy. And they can produce some work, right, for getting you some revenue. So having more nodes is an improvement. The more nodes you have, the farther away they are, the more people you have. That's what Ethereum always wanted to have, people from their homes running the network and having them anywhere. If you cannot have that and you have a few institutions running everything, then what's the point? Then you have a centralized entity, right? So we want to bring home stakers, as many as possible. That's the main goal. But that is not the only solution, because you could be a really, really wealthy home staker, right, and have all the validators. So we need to work also on the level of this decentralization, which is not necessarily that they are all across the globe, but they are also connected across the world. What does it mean? So if Vitalik in the post also wrote something about this, which is the connection between the nodes needs to be random. And it's something we're doing, and I think you saw it, Kevin, on the talk that I mentioned at the beginning. At Diva, we are randomizing the connections between these node operators. So when you're going to be part of a validator, you don't know who is going to be your set. And that is really important to have a fully entangled network of connections. If you didn't have that and you always end up with the same group of people, then this group of people control a big portion of the validator. So in order to have a big decentralization, you need to connect them randomly. So then virtually, if you need to collude with the whole network in order to attack it, right? So that's the big part, I think, in what we are doing in Diva.
Yeah, I think it would be interesting to get a little bit under the hood of how that's actually working. So like, how are you creating the randomness when it comes to how these individual entities are bundled? And then also, what does it look like from there forward until they're actually validating a block?
So there is a talk very interesting if you want to see the details on the presentation, because I don't have anything to present right now. But the idea is that we take randomness from the RANDAO, from the Ethereum natural randomness that is produced by the whole set of validators, to create like seeds, like lottery tickets. And these lottery tickets are assigned to each one of the nodes participating in the network of Diva. And then what we do is like a bingo. You need to come together with the lower set of lottery tickets. And there is not one is going to win, because it could be that the 5 better winners are not going to be available. So then what you do is that you choose the second best or the third best. So it's like a competitive process in which everybody can win. But of course, like if you're the one with the lower set of tickets, then you know you can win. So you will be there proposing yourself to be part of the validator. So it becomes like a random process based on the entropy of Ethereum that becomes like it's like a proof of work, or like a lottery to select these connections. And then based on that, you use that set to create a validator.
Okay, and then once you've used the RANDAO as the source of entropy randomness, how do you communicate out to the nodes to say, hey, you're part of this random group?
The nodes already know. They only have to look at the RANDAO node. So it's a deterministic algorithm. Therefore, it's not something that the smart contract needs to tell. They just, by looking at the blockchain, they see, okay, I could be the winner on the next stage. So I better start to work with my rest of colleagues. I'm going to choose that one, right? Start working, creating a DKG, which is another concept we need to introduce, is distributed key generation. And it's the process of creating this validator key in a distributed way. So they do a DKG, and they propose this validator to the smart contract. And the smart contract is able to verify because it has the knowledge of this RANDAO, and it has the knowledge to see, okay, you have this lottery ticket, you have that lottery ticket, I'm able to verify this data, and you propose a valid validator, therefore I accept you. And now later, someone comes with a better lottery ticket, the previous one got removed, and the new one is the latest winner, right? So you have a process in which there's a period in which anybody can be a winner, and there's like a competition who makes the best bid, let's say. And then at the end of the period, the one that won can register the validator and start operating and validating directly.
And when you say there's like a competition, is that based on who can produce the block with the most profit or something else?
No, the process is, again, like completely random based on the identities of each one of the operators. So it's completely random. And the idea behind this is that, well, DVT already compensates by things like geographical location, because you have this distribution of nodes, right? You don't necessarily need to optimize for the lowest latency and the nodes connected. Otherwise, what you will end up is every node will be on a data center connected to each other, and they will all be in a single location. So since we cannot guarantee also geographical decentralization, because you cannot control where people are, they can fake location, and there is no proof of location that can be used, the only thing you can do is really entangle them and connect them all together, and expect the whole validator behaves with a good performance. If then over time, after a validator is created, the performance of that set is not good enough, there will be triggering mechanism that will exit that validator, and another one will be created. And over time, the network will tend towards a stable, good performance set of validators. But hopefully that's a very rare case, and the latency that we have seen so far don't tell us that there will be any issues on this mixing of nodes.
That makes sense. Yeah. I mean, at the very least, that's a good preventative measure in case there was like a malicious actor that wanted to spin up a bunch of faulty hardware and try to attack Diva. The idea there is that it would start to kick those off of the network. Is that right?
Yeah. And also, if you don't distribute them like that, imagine that all nodes were in US or in Europe, let's say, right? And you put them in a single location. Let's say they are all in London. Then if you are too far, and maybe you have a lower latency, lower performance, everybody should want to be in London because that's where you have the lowest latency and the best performance. And then if something happens in London, the whole network could go down and cause damage, because in Ethereum there's also this correlation penalty that can happen and damage more validators at a single time with a higher penalty. So yeah, it's important to keep the nodes random and decentralized.
Okay, I want to play back my understanding at a high level of the major pieces here, and then you can fill in the parts that I've missed or that are worth more detail. So there is the sort of goal of matching staker funds to node operators. And in order to do that, you use RANDAO for randomness. It's unclear to me who's doing the work of the DKG generations to like generate the key shares and distribute to those nodes in the clusters. So maybe you could dive in there.
That's a very good question as well. And glad you asked. There are two main types of technologies here. One is called Shamir secret sharing. Shamir secret sharing means you have a key at a single point in a single machine, you break it into pieces, and then you distribute that key to many nodes. So then if you have 5 nodes, you take the key from here, break it into 5 pieces, and send it to 5 nodes. And then you have a threshold of 3 out of 5 and so on, right? And that's Shamir secret sharing. That is breaking from one to many. But distributed key generation, there is not a single machine that is producing this thing. They do, all the machines, a multi-party computation, and they all agree into a key together. So the key never existed at a single point in time, and therefore cannot be taken from here and installing and used anywhere else. So the nodes themselves pick each other, and they talk to each other to generate the key distributor.
Interesting. So there is no single source, no computer that holds the private key. It is just this amorphous collection between all of the operators where they aren't able to just like piece that together, at least individually.
I know there's also some nuance around what type of MPC implementation or like standard projects use sort of across the space. And so I'm curious, when you think about the actual cryptographic standard that you're using for that, what was the decision-making criteria there? And how did you decide that the model that you're using is the one that you wanted to use?
Yeah, so why DKG versus Shamir secret sharing? Well, Shamir secret sharing imposes a risk at the end, right? You have the keys virtually at 2 points where you generate them, and also on the set of nodes. So you cannot guarantee that the node that generated the key has deleted that key. It could use it, it could sell it, it could still keep the key, and it imposes a risk over the whole validator. So that's the first thing. That's why DKGs were better on that sense. More complex because you need to coordinate. So the communication complexity is quite high here, and the process needs to be as trustless as possible. So it's a bit complicated to implement, way more than Shamir secret sharing, but we thought that it was the proper thing to do, and yeah, we built it and we have the implementation. And now inside the DKGs, there are many implementations. And DKG at the end is a protocol. So DKG uses Shamir secret sharing below. So Shamir secret sharing still used, but it's used like some kind of process that each node runs, and then they exchange some messages between all of them. So among all the DKGs protocol that were out there, we decided to go with the most popular one. This one by Kenaro from many years ago. It has been proven to be secure for BLS curves, and Kobe Gurkan, who is a great cryptographer, talked about the security of this model. So we assumed that it was gonna be good. And the only concerns about the protocol that we chose was the disputes, like what happened when one node of the DKG is malicious and you wanna challenge it. But the good thing of that is that since we have this competitive process in which anyone can submit another DKG, and we don't have one DKG, we have many DKGs running in parallel, if one set gets invalidated, it doesn't matter. You don't need to process or do anything. Another one will win. Or if not, another one will win. And if not, another one will win. So that's why we choose this protocol, to have something between simplicity, but at the same time, proven mathematical performance that's going to be safe for the conditions that we are applying it to. But yeah, the cryptographic implementation, like all the primitives and libraries, are things from Herumi, like standard cryptographic libraries that Ethereum already built. And yeah, we shouldn't build any one. That's a super risky thing to do. So we are using good libraries from clever people than us.
Yeah, we just had Asta, who's the CTO of Privy, on the podcast, and it's a different situation, but we were talking with her around why they use Shamir secret sharing, and her point was kind of like, it's just so tried and true. It's one of the few things that we know works, and so it feels like there's definitely a balance here between security and the amount of flexibility that you want for a system, particularly that, to your point, encourages, I don't know if competition is the right word, but at least the ability to have individual nodes swap in and out if something doesn't work.
No, I agree 100% with the safety and security of Shamir secret sharing. That's why I said that we use under the hood on the DKG a proven algorithm implementation of Shamir secret sharing. Like, we use Shamir secret sharing because the MPC, the DKG itself, uses Shamir secret sharing. But the DKG is more about the protocol complexity, about the exchanging messages, not that much about the cryptographic implementation of the Shamir secret sharing. So that's why we could reuse and build on top of giants, as you say, right? We use the technology is already well tested to create a protocol to agree on this kind of keys.
So now that you've put all this work into having this randomized set of operators and this sort of like competitive nature to being able to propose a new block, I'm imagining one of the side effects of all of that work is that you have redundancy. If a node fails to propose a new block when it's supposed to, there's like another node behind it to pick up the slack and like make sure that it doesn't miss its opportunity. Can you talk a little bit more about what are the side effects and the benefits to doing all of this work?
So you has correctly said, we have this set of nodes that the beauty of it is that you have a threshold, which means that as long as the threshold is alive, the whole validator should be alive. But that means that if someone is now doing the aggregation job and is becoming like a leader inside of the system, if it fails, someone else needs to be doing that job, right? And you need to have different roles inside of the same set. That protocol, we are still building it. Like, we have decided all the implementation details, but that's the process that we are going to launch next on testnet, the consensus protocol, to be able to have this resiliency. Otherwise, you don't have fully all the DVT capabilities on the nodes. But the trade-offs that you have here is, well, since you have to agree on stuff and you have more nodes than if you have a solo staker, by definition, you're going to have longer latencies, longer times to decide things and to sign messages. And so one of our concerns was, well, MEV is already imposing a lot of delays here because you have to go to the MEVs. They have incentives to wait as long as they can to produce the block with maximum amount of transactions and the maximum MEV, and then they send you at the latest millisecond to try to get and squeeze more revenue. So MEV already increase a lot the delay of response, but in order to have an inclusion distance of similar to a solo staker, we have up to 4 seconds in general. So we have found out that at least in the network currently, we are inside the range that doesn't really make a difference between solo staker and DVT. So luckily for us, doesn't really look like it's affecting much. But yeah, technically, like if you have disagreements inside the same set of nodes and stuff, it could create some kind of delays to the signature process and to the validation.
That makes sense. So there was a recent news around, I don't know if Diva will use the term, but Diva vampire attacking Lido. Can you talk a little bit about what it is that Diva is doing to sort of like incentivize people bootstrapping the protocol?
Sure. First of all, I'm talking from the Shamir Labs team, which is the developer team, right? So this incentive program has been done by DAO, decided by the DAO, together with Msign. Msign were the former Melonport guys, so you probably remember them. They have battle-tested smart contracts that you are able to create balls. They are audited. They are open source. So they proposed this solution to the DAO in order to pre-capture some ethers and commitment to people that already wanted to use Diva, that believe in this solution that was going to be the most resilient, becoming part of the DAO, let's say, right? So the DAO proposed this incentive process by just staking some ethers or STETH into the vault. You lock them and you earn some Diva tokens based on the time that you keep them locked. And hopefully, if we launch not too far from now, these ethers and STETH that are there on the vault will be converted to the Diva staked Ether, and that amount of Ethers will be transferred to Diva. So yeah, we can use it to create some real validators and not just lock them there on the vault.
Got it. Yeah. So it sounds like there's still a little bit of building time that you need to iron out, make sure that the protocol is to the standard that you want it to be. In the meantime, there's this additional layer where people can stake either ETH or STETH and then earn rewards up until the point where the protocol launches, and then that gets converted in to, what is the name of the Diva staked ETH token?
Yes, the Diveth.
Oh, Diveth. Okay.
Yes, that will be the staked Ether. The Diva token for governance is Diva, that is not used for governance. The staked Diva, the token when you lock them, that token is the staked Diva, and that is used for governance only, and that's the one that people use for delegating and for voting. So we have in total, like you could say, 4 tokens. The staked Diva, the Diva itself, which is valueless, you can transfer them, but you cannot vote with them unless you stake them. Then with the delegated Diva are the ones that can vote. Then you have the Diveth, is similar to the STETH, it's a rebasing token. And then you have the wrap Diveth, which is an ERC20 that can be used for DeFi, transfer it to other chains, and so on.
You mentioned Diveth is a rebasing. Remind me again what the other alternative to a rebasing token would be, just like an interest bearing.
Sure. So rebasing means that you have 2 ways of changing the value of the token. So when there is some change on the beacon chains and the value of the validators increases and you have more Ethers now suddenly, or you generate some rewards, you can either send a transaction to each one of the nodes, right? Or put them into a pool, so you have put all the rewards there and you increase the shares. But then that means you have to send a transaction of what is the shares change or the amount of Ethers that each person has received. So that is more costly, let's say, on gas. You need to send a transaction to each one of the people that are receiving this increase of rewards, because each token only represents 1 Ether and it doesn't increase in value. So what a rebasing token does is it doesn't send you a transaction, it changes your balance on the wallet, which can sound a bit scary at the beginning. But if you do it through an oracle, as Lido is doing it, it also sounds a bit scary to me. What we are doing, and we are working towards this process, and Lido is also working towards this process, so I'm happy to see that Ethereum is moving in the right direction, is to have a zero-knowledge proof of all these changes. So when you have a zero-knowledge proof of all the changes that have happened, and you send it to the smart contract automatically updates the balance of everybody without the need of a transaction, without the need of a gas cost, and you see the balance of your Diveth or increasing or decreasing automatically based on what the network did. But there is no way to manipulate that because it's purely a proof. There is not anything that you can change.
That's super cool. Yeah, I love how every little corner of this, it's clear that there's just a lot of thought that went into it.
And a lot of pain, Kevin, and a lot of pain.
I mean, we talked about so many different things. We talked about the existing ecosystem around what it looks like for a large percentage of staked ETH to be in an individual protocol. We talked about some of the distributed validator technology stuff. We talked about why you're using certain MPC implementations. I'm curious if there's anything else that you want to call out as something that you think is really exciting about Diva and how you're approaching this challenge around staking.
You guys have done a great job at asking me and pointing me at the most tricky questions and all the little details. But yeah, MEV, I wanted to emphasize, is super challenging. I think it's one of the most challenging topics right now. And it could seem very naive at the beginning. But since you have this centralization force, since you have this group of builders that are building the nodes, we have, for instance, a trade-off here at Diva, and any other liquid staking protocol have, which is, do you use MEV or do you not use MEV? And then you can go a step further. Do you allow MEV or you don't allow MEV? Or do you enforce MEV or not enforce MEV? And if you want to enforce it, how do you enforce it? Because if you enforce it, then you depend on a set of builders that are, centralized and so on. So there are many layers here of what is the proper trade-off, because people want, like the stakers, they are going to want the maximum APY. They are not going to say, okay, you can be as ethical as you want, but if you say I don't use MEV, I'll go to the other protocol, which gives me a higher APR, and then as MEV. So we need to include this thing, but include it in a decentralized way. And that's where we are facing the most struggling on how to include it. Because we need to include something that, in our opinion, is quite centralized and it's not part of Ethereum without the PBS implementation, like the proper PBS implementation. So that is something that hopefully we see changes. And yeah. And another thing that now came into my mind as well is something for the exits. How do you trigger exits of validators? So currently, even if you want to redeem your ethers, you want to get them back. Right now, you have to ask someone, please, can you exit the validator so I can get my ethers back? And they need to sign with a private key so that you can redeem your ethers. Great, but then you're still in the hands of this group of people or one people, if that's in Rockpool or Lido, right? So what we are looking forward, and Danny Ryan was in conversations also with us and other people, is to have a way to trigger exits from the smart contract, from the execution layer. So if you are able to call for an exit of a validator from the withdrawal address of a validator, then the liquid staking protocols will be able to push for this, say, I want to exit this validator, and then send the ethers back, even if the validator is behaving badly, they have lost the key, they're trying to attack or kidnap the ethers. Doesn't matter. You can always recover them from the protocol. So that's another exciting thing. And the third one, last one, promise, is a Web3 signer. So Web3 signer is something that we are using for connecting the client to Diva. It allows us for many more simplicity than other protocols, but there are some drawbacks. And it's that consensus, when we define it, they assumed that was going to be, so like the whole Web3 signer was defined as a trusted connection. You're going to have your Web3 signer where you keep the keys and your validator where you validate, right? But if it's not trusted, then what happened? Like in our case, it could not be trusted. It could be an untrusted connection. So we need here to introduce a modification of the Web3 signer. And the Nimbus team is doing a great job with us to make a modification of a verifying Web3 signer where you can verify things like the fee recipient. If you don't have a verification over the fee recipient, what a node could do is send you a message to signed that you don't know where the fee recipient is going, where the fees are going of the validation, right? And they could steal the fee. So in order to avoid that, if you can see the fee recipient, you forbid anybody from doing this kind of stealing of fee recipient. So that is something that as well we are working, and as you see, many fronts of many little details here and there, but yeah, hopefully they all come true, and we have a beautiful protocol out there working stable.
I feel like all the little details matter a lot when you're talking about something as important as the
yeah. If you forget one, hopefully we are not forgetting any. But if anybody on the audience or you guys think of any, please feel free to comment and give us your thoughts.
Yeah, it also goes to show you how you're not introducing too much complexity into the system, but every little interface that you have, because you now need to account for this additional. You now have, many different operators make up one node. That means that you have to go update the Web3 signer and go update all these other places where there were just assumptions built into the system that one node equals one operator. So yeah, I appreciate that. It seems like your team and yourself, you've put a lot of thought and work into this project. Now, for anyone that's interested in learning more technical or non-technical aspects of Diva, where would you point them?
They can go to the website diva.community or to our Discord channel. So it's Discord/Diva. So you can find us also in Twitter as Diva Staking or Shamir Labs. So in our case, we are like the developer company, as I said, and you have documentation there about how to run the testnet, about how to run a validator, and hopefully we can start creating more documentation. We know we are lagging a little behind on the documentation creation, so people can have more insights about all these things that I'm talking, but we never find the time to properly write it and put it on paper. So hopefully people can see what we are building and help us also and contribute with ideas. Yeah.
Beautiful.
So yeah, as a summary, shamirlabs.org or diva.community to find more about Diva.
Amazing. Well, Miguel, it was so wonderful to have you on the podcast. Thank you so much for joining us and talking all things Diva.
Pleasure was mine. Thank you for inviting me. Looking forward for the next one.
Appreciate it, Miguel. Thank you.